Hello, everyone. Welcome to the Elixir Roundtable. My name is Brooklyn Myers, and I'm the instructor for DockYard Academy. This is my very first time hosting, so I want to give a huge thank you to everyone for having me. Today, I'm joined by several awesome DockYarders and some of my amazing students. So we're going to start our round of introductions. Everyone, can you please tell us your name and your title?
Hi, everyone. I'm Paul Schoenfelder, Principal Engineer at DockYard, and yeah, I'm just happy to be here, talk with you all.
Hi, I'm Benny Rosas. I'm a software engineer at DockYard.
Hi, I'm Andrew Berrien, an Elixir engineer here at DockYard.
Hey, I'm Drew. I'm host of the Citizen Coder podcast, and I am a DockYard Academy student. Thanks. Glad to be here.
I am Brian Cardarella. I am the founder, CEO of DockYard. I'm also managing our research and development projects.
Hi, everyone. Rockwell Schrock, Senior Software Engineer at DockYard.
And I'm John, another student at DockYard Academy. Very happy to be here with you all.
I am very appreciative for all of you who have come to join us today. And my understanding is that, Paul, you've been working with Rust. Rust is something I have, I think, a hello world level of understanding with. That is about how far I've gotten with Rust. So I'm really curious to hear what exactly you've been working on. And yeah, would you mind telling us a bit about that?
Sure, yeah. I mean, I think Rust has turned out to be as fun a language to work in as Elixir for me, but they scratch very different itches. But the reason why I'm doing a lot of Rust right now is because I'm working on a project called Firefly. Many of you probably heard of Lumen because we gave talks about it. Starting, I think the first one we gave was in like 2018, right, Brian? Or is it 2019? It was the first one. But we gave a couple talks at a few different conferences about this project. The goal was to bring Elixir to WebAssembly, be able to write front-end applications using the full suite of tools that we're used to on the back end and kind of, unify the two. We ended up renaming the project because there was about 15 million different Lumen variety projects out there, so we picked something else. It was highly unique, definitely not any other Fireflies out there.
I know,
but
it got to the point that, I think for me, the tipping point was the TV show Severance, where the bad company was called Lumen, and then there was the what was the 3D engine where their spectral lighting system is called Lumen. There just seems to be Lumen this, Lumen that. So
PHP has Lumen too.
Yeah, but I don't care about that one. Like that was the first thing people brought up on Hacker News. I was like, I don't give a shit. Like finding unique names in software at this point is pointless. But amongst like everything else, that was problematic.
That was the only one that didn't bother me either. It just became so overwhelming in so many different domains that it seemed like, okay, probably better to rename it. But in any case, like the project is now called Firefly, and this year, I think 2019, 2020, 2020, I left DockYard because Brian was also stepping away from being CEO. So kind of the project was going to be winding down a little bit. And so I went and kind of did some other stuff for, year and a half or so. Brian was coming back to be CEO of DockYard again, and he reached out to me because we had been kind of keeping the project, the pulse there, but it was limping along, not really making much progress.
It was like Walt Disney style life support option.
Yeah.
It was on
deep freeze.
Deep freeze.
But he was like, "Hey, are you interested in coming back and continuing to work on this?" And so we resuscitated this year. A lot of work has gone into the project to kind of bring it to fruition. The compiler was kind of the major last outstanding piece. There's a couple different things that tie into that, but kind of finishing the compiler was the major blocker for us, when I had left the company. So coming back this year, that was kind of the major goal. That was completed over the summer, just prior to ElixirConf. We got that kind of wrapped up. There's still some tangential work going on around that, but now we've shifted focus more towards like the runtime aspects of it, making it actually useful to be able to run real world Erlang Elixir programs. So Firefly is, sort of fundamentally an Erlang compiler, but through that, our goal is to support really any Beam language, because they primarily, compile to Erlang abstract format or Erlang core format. Those are two kind of like intermediate languages that the Erlang compiler uses internally, and our compiler can support both of those. So by being able to kind of ingest any form of Erlang source, we can compile Elixir programs, Erlang programs, potentially any Beam language. And so right now our kind of active effort is trying to flesh out the bits of the runtime that are missing, that we can actually start to use this for real. I've been working on the last couple of weeks, actually, since ElixirConf, really trying to get our like async runtime stuff figured out, because that was kind of the last major piece of the runtime that was blocking some efforts from Elle in particular, who was working on kind of like the runtime library aspects. And I'm hoping to have that wrapped up here in about a week or so. With that, I think things are going to really start to take off in terms of what we can do. We can start to bring more people in to contribute to various parts of the standard library. And it becomes less and less bottlenecked on just like one or two of us working on like very complex sort of roadblocks, which has largely been the state of the project for, since it started. There's just so much ground to cover. We ended up taking, a path of like kind of building it up as a new ahead of time compiler versus trying to port a virtual machine to the web. There's a variety of reasons for that, but, suffice it to say that meant that we had to really kind of build a lot of stuff up from scratch. There wasn't much that we could reuse. So it's been quite an adventure on that front, but, for those who were excited about it when we started, talking about it and introducing it to the public, like, there's hope that you'll be able to start playing with that quite soon. So happy to answer any questions about that, at any point. If anyone reaches out to me with questions about it, and we're certainly, interested in anyone that's, excited to contribute to that stuff. So
that sounds like it would be a phenomenal project to learn from, like getting to actually see how you're building a compiler, everything that's going on in the hood with Rust. I'm sure there'd be a lot
that's
of
one of the things that I love about it, is that it's very much like one of the goals for me is that it can be used to teach people how the Erlang virtual machine does what it does. It's obviously different than the Beam, but it's much more approachable in terms of reading the source code and kind of breaking things out into the little component parts. There's certainly aspects of it that are very complex, but I think for me, it was being able to really understand all aspects of the Beam, the runtime, how the language fits together, why certain decisions were made. I feel like any sort of project like this, it sort of like re-implements a language from the ground up, sort of fundamentally has the opportunity to do that kind of thing. But it's a tricky balance, right? Because you have to take a lot of shortcuts in order to get things done in an efficient time frame. But at the same time, you want to keep it sort of accessible, right? Because it makes it easier for people to contribute, and also just makes it easier to come back and maintain. I've been pretty happy with how things have turned out for us on that project, because for myself, taking a step away from it for, about a year or so, hardly touching it in that time frame, like I was able to come back and really be productive in that code base without having to like relearn everything from scratch.
I think
there's not much better test for that.
To add to some of what Paul's talking about, like the web specification also matured during that period of time. So some areas where They were having to work around deficiencies in the specification. They've been able to incorporate some of these new things in there. We're going to have a better compiler and runtime moving forward than we would have a year and a half or 2 years ago. And I think maybe if Elle was, she's on PTO this week. If she was on, she may bring this up. And I bet Paul probably agrees. But one of the things that they've really been that's been interesting to see, but also a bit of a struggle for them, is they are essentially feeling around in the dark at times. Like there is no spec on the Beam. There's no spec on the virtual machine that exists in Erlang. They're really reverse engineering it. They're having to go through what tests are available there, figure out what it's doing, and re-implement. And so in some ways, the clean test suite that they're producing could potentially be looked at as a form of specification in the future if we wanted to go down that road. I think that it's going to be I have very high hopes for the project. My focus for the moment is on the LiveView native stuff, but this opens up a lot of doors for potential on where Elixir and Erlang can play in the future. So I think it's a incredibly cool and versatile and potentially incredibly impactful project for the community.
Yeah, that brings a really good point, Brian, that I wanted to ask Paul, was like, do we expect there to be sort of performance characteristics, like differences between the Beam and how Firefly is running in terms of, I don't know, just, async and scheduling and all that stuff? Again, it sounds like you don't really know how it's implemented necessarily.
I think it remains to be seen still to what degree benefits around performance will manifest. There are some things that I can say with a pretty high degree of certainty. One is that we will be able to target smaller devices, more restricted devices. The actual code size of what gets deployed will be far smaller than your typical Erlang release. As far as like actual execution speed goes, that's going to be hard to tell at this point. We're going to have to do a lot more real world benchmarking once we get a lot of the runtime fleshed out. Because I think unless you have a real comprehensive like example application there, it's pretty easy to sort of contrive results that kind of show one way or the other. But from my perspective, some of the opportunities that we have, because what we've done is we've said, all right, we're not going to support hot code loading, for example. That cuts off some capabilities from programs that target Firefly, but at the same time opens up a world of optimization opportunities that are just simply not available to Beam applications. And that's part of the reason why we get space savings as well, is because we can do a lot of aggressive dead code elimination that just can't be done on the Beam. We also have, kind of some ongoing discussions with projects, like NX, for example, and trying to find ways to take advantage of our native code generator, tying that into projects like NX, which are gathering type information to be able to, sort of generate native code from ML models and be able to make that sort of a natural integration point with Firefly, so that you could take a program that's written in NX style, compile it with Firefly, and get much better native performance than you might get with running it on the Beam. It remains to be seen how that can tie in, but that's something I'm excited about.
Another thing that Paul and I chatted about briefly does tie in with LiveView native. So one of the real pushback questions we always receive early on is, what about offline mode? And Garth Hitchens had this really good idea of using Elixir Desktop to package up the Phoenix LiveView server, run it on device, have it produce with the LiveView client, the LiveView native client, still produce the same experience of being able to build LiveView native applications. But then you have a locally run Phoenix server on device that, through either a CRDT mechanism or some other data synchronization, when the network's unavailable, it will stage and then eventually synchronize the data. When we compare it to React Native has about a 50 to 55 megabyte footprint size for a hello world application. Elixir Desktop is in the 30 to 35 megabyte size. But the potential there in the future is to either recompile Elixir Desktop or do something from scratch with Firefly, which is going to put us more in the vicinity of below 10 megabyte, potentially below 5 megabyte in footprint size. So there's just like, I don't want to make it seem like it's a cure-all for everything, but at the same time, it's exciting because there's all this potential that's there on what can be done when we get past the point that Paul and Elle are currently working on.
And I really
Very
think
cool.
it boils down to making, different trade-offs. If we tried to basically provide 100% of what the Beam provides, you end up with something that's basically the Beam, but half-baked. By making a different set of trade-offs, though, we can make it very useful for certain domains and be able to benefit strongly from it and actually have like a reason why you would use Firefly versus the Beam. Like, I think Brian would agree that if there's always like, I can use either Firefly or the Beam for this problem, then you're always going to choose the Beam, right? Because it's battle test, it's been around forever. There's a lot more like, support behind that project. However, if we can make it so that there is a real differentiator where you're like, I can't use the Beam for this, that's the niches in which Firefly is aimed.
Yeah.
That's what we're really trying to target with this project.
One of the Beam's biggest selling points, as Paul just said, is how battle tested it is, right? And like, that's just not something that we're going to be able to provide because we can't just drop 30 years of production right. Real world stuff immediately. Mm-hmm. And so it's going to, there's absolutely going to be comprehension on adoption. There's going to be saying, I wouldn't imagine that any of the core team on the Erlang core team is feeling competitive with this in any way. I'm hoping that it's always looked at as a complementary effort. We're not trying to replace, we're looking to augment and extend where the kind of programming models of Erlang and Elixir can work. And that's really our goal here. And so like we've seen how well Erlang works as a server-side technology, working in these, traditional server-type environments. And, what are the reasons why it has not really made significant market penetration with IoT devices, for example? Like Nerves is a fantastic project. And I think by all measures, everyone looks at it as being almost magical in the ways that it, what it can bring towards IoT. But you're still looking at a minimum 20 megabyte footprint size, and that right away, kind of takes you out of consideration for many IoT applications. So, there's room there in that space to bring in many of the values of Erlang the Beam with Firefly, and I feel like that is more than enough ground that isn't going to step on the toes of the Beam itself, where we can live comfortably and everyone can thrive.
For sure.
I love the vision of this project. I do want to ask, because this is a domain, like you get to solve a lot of problems that I think many developers don't get to encounter in kind of traditional web development or whatever environment it is. You get to get closer to Elixir under the hood, Erlang under the hood, talking about building a compiler, right? And I know that my students in the room, their words they haven't heard before per minute is probably pretty high right now. Steam's probably coming out the ears. So I would love to know, to kind of get this on the teaching side and the learning side, how can people learn more about these topics? How can we make it more approachable? Whether the resources available, where do you start learning it? Because if you told me, hey, you're going to make a compiler, wouldn't necessarily know where to start with that, right? It would be totally different than what I've done before in the past. So yeah, Paul, I'm really curious your perspective on that.
Yeah, I mean, that's an excellent question. And honestly, it's a tough one to answer too. But I mean, part of why I sort of like signed up, volunteered for this project was compilers have been something that I've been interested in since pretty early in my career. I was always fascinated by, how they work and how you actually get this high level stuff to turn into something that runs on the machine. And so over the years, I had, kind of worked on little projects that sort of built up like piecemeal the things that resemble a compiler, right? Starting with learning, how to parse in different ways, building things like calculators and so on, like real sort of toy projects, but at the same time, like that you start to get a feel for some of the techniques involved. I did a lot of reading and research when I started trying to like build in my spare time a real compiler. It was supposed to basically be a statically typed, pure functional language that sort of mimicked how Erlang's concurrency model worked. I think that's where, I had the most trouble, because I was coming at it from like, I need to learn how type systems work and how to write like, a code generator and all this stuff. And it's really easy to kind of like get lost in the weeds a little bit. There's a million different papers out there on programming language theory and new techniques for doing various things. And you can find yourself sort of spinning your wheels a little bit. I went through that phase quite a bit. But at the same time, I was learning a lot because I was spending time implementing some of that stuff, looking into how other like toy languages and compilers were built. I think that's one of the most useful things for me, and still remains one of the most useful, I guess, paths for like learning things, is seeing how real production compilers implement some of this stuff. So because I'm particularly comfortable with Rust, I did a lot of digging into how the Rust compiler was implemented, and still do on a regular basis to see how they do certain things. And there's a lot of really helpful projects out there that implement like a C99 compiler in C, and they're very small. The Lisp languages in particular are very useful for this kind of thing, because you can build a programming language compiler with a native code generator in Lisp in like 300 lines of code or something. It's absurd. But that makes it really easy to start to understand like, oh, I don't actually need all this crazy stuff to build something like this. I just need a few tools that do what they do, in a straightforward way. It might not perform well, but it works, right? And you can kind of build up from there. The Firefly compiler, benefits from a lot of those lessons I sort of learned the hard way, I guess. And some were learned while working on this project too. So it's not to say that like I knew what I was doing when I came into it. There were still areas of this project that I was uncertain about, that I needed to do quite a bit of research on. And some of it that evolved along the way as we started to understand like, oh, well, the WebAssembly spec is not going to evolve to give us multiple threads anytime soon. There's not going to be like stack switching primitives that we can rely on anytime soon. And so we started to have to like rework how we were implementing the compiler to work around those constraints. Like this compiler would have been done like 2 years ago if I didn't have to work around those problems. But the reality was that we had to kind of like reinvent this from scratch in a way that, would work across multiple platforms. But I do think that the best way to learn this stuff is to sort of give yourself little problems that you can tackle that focus on one thing. Like I was saying before, like parsing challenges, for example. Like when I wanted to start learning how to like really understand how parsers worked, particularly ones that deal with expressions, because that's where you get kind of some of the more interesting parsing problems. A calculator was a fun project to write. One that handles, like basically the full language of arithmetic, I guess, for lack of a better way of describing that, because then you have to figure out like operator precedence and things like that. It's a simple thing to parse, but dealing with some of those, like, how do I deal with associativity and things like that? That is something I wouldn't have known how to deal with until I tried that out. Awesome. I think now this, state of the industry, I guess, is improved considerably. There's several like good books out there on learning to write compilers. I forget the name of it now, but there's one that's written in Go by someone who worked on real world production compilers, and I think still does. I think it's like writing a compiler in Go or something like that. I don't remember off the top of my head, but regardless, the point is that, the wealth of knowledge that's out there for like getting into working on projects like that did not exist when I, started getting into it. I mean, there was some of the classic stuff like the Dragon book and whatnot, but I found those sort of difficult to get into, and I can't say that I really learned too much from those. It really took like getting my hands dirty for some of those lessons to really sink in.
I think I can summarize what Paul was saying is that compiler work it always feels daunting, but it's never been easier to get into it than it is now. And like a lot of that, like the amount of data out there and ways to do it, it's actually a good exercise, even for junior engineers, to just like build a simple compiler. I think it's a worthwhile exercise. It gives you a deeper knowledge as to what's happening behind the scenes of your language, because those lessons on parsing and then compiling are going to carry through pretty much on every single language that's out there, especially the ones that are going through LLVM for compilation, because LLVM, for those that are not aware, does work that languages used to have to do individually and kind of decide on their own what to do. Whereas now it's like this one library, this one system that you give into it and it gives out at the end. And so if you can build for LLVM in your own little basic thing, I mean, that is a cornerstone as to what like much bigger and more complex comprehensive languages are doing.
Yeah, you basically get a production code generator for free if you target LLVM IR, and it's hard to overstate just how much engineering effort has gone into that. It's like probably hundreds of thousands of man hours at this point. I mean, it's crazy how many people have worked on it and for how long. It's been 20 years now since I think the first release of it. Quite some time now. But as a result of that, you get something that takes care of a lot of problems that would otherwise require you to invest immense amounts of time. I'm not sure, like it's a trade-off. If you're trying to build something that's like sort of production ready, LLVM is almost a must in my opinion. But on the flip side, if you're building a little toy compiler, I would suggest not using it, only because you'll spend as much time learning LLVM as you would have spent learning how to like work with assembly code or write a naive code generator. And some of the things you learn doing that are interesting problems on their own and are directly applicable to then using LLVM on another project in the future, because now you'll understand what it's doing for you, how to reason about the output you get from it. So if you're trying to figure out like why something's broken, it's very helpful to actually understand like what it's doing for you, basically. But yeah, it's pretty amazing like how beneficial that's been, at least for us. I mean, it has taken care of a lot of problems for us.
One of the common parallels I'm seeing, I'm really curious to get a bit of a pressure sense on Drew and John in hearing this, because one of the parallels I'm seeing is you're solving this, fairly advanced problem is something that we've talked about in class, which is solve a simpler problem. Anytime you're faced with a challenge that is beyond your current ability, solve a simpler version of that problem and make it as simple as it needs to be. The only difference is that you're working in an environment where the problem is significantly more advanced than what we're seeing, week two of the cohort.
In other words, Brooklyn, in my software engineering career, I've never regretted trying to go above my ability, trying to do something more than what I thought I could do. I mean, not clients, not for billable time, in terms of like my own personal time, open source work. And that's why open source work is so important, because it gives you that playground to experiment and push yourself beyond outside your comfort zone. I mean, that's just a general rule in life, but in software, I mean, that's the way you get better. You got to keep pushing forward. And compiler work can be seen as like almost like one of those top level type skills. And even at a small, even just like a small like nugget, little basic, like funny little language you may implement is going to give you a lot of street cred, but it's also going to like really open up your mind as to what is happening during the runtime of the languages you're normally using.
Yeah, I mean, it's certainly a great way to learn just like how programming languages really kind of work under the hood. But Brooklyn, I think you really kind of nailed something on the head that I didn't really vocalize, which is that when working on this project, you're exactly right. Like it's a huge project. It's extremely complex. So how do we tackle that? You know, do we just sit down and start writing it? Kind of, but I think the way that I approached it was to divvy it up into smaller problems and tackle each one of those things sort of in their turn. Sometimes that meant like, okay, I'm going to work on this part of the project up until this point, and then bring some other part of it kind of up to sort of support that work, and then use that as a foundation to build yet another piece of it. So there's a little bit of like an ordering problem there, figuring out what you start on and how you kind of progress through the project and the various phases of it. But by breaking it up into smaller and smaller pieces, and you just kind of iteratively do that until you have a chunk that's like somewhat easy for you to wrap your brain around and you know, has a time span on it that's not like undefined, then it lets you really feel like you're being productive with it. The times that were toughest with this project were ones where I was working on something that had no clear answer to them, and I wasn't sure whether or not the solution that we were following was even going to be ultimately the right one. Why that was a problem is that I couldn't break it up any further, but it also meant that I never knew where I was in terms of total progress. Like, it was kind of one of those things where you know it's going to be done when it works, but before that happens, you don't know if maybe you're going to have to throw all of it away and start from scratch. Avoiding those kinds of, I think, situations is paramount. And I think that really applies to sort of any engineering problem, really, is trying to limit the unknown unknowns as much as possible to the point where you have a pretty well-defined problem.
And this is DockYard internal matter to a degree, but I don't mind talking about it publicly, is that, you know, we've been looking for a product owner for the R&D department. And it's been a struggle because most managers that have traditional product owner training aren't a fit here, because, you know, what Paul just said is, you know, sometimes you have to try something out and throw it away. Imagine trying to estimate around that. It's a nightmare. It's impossible. And, you know, most managers want, you know, let's come up with an estimation. Let's hold your feet to the fire. That's not the way that, especially, you know, software development, research development can go. There has to be an allowance on, you know, experimentation. There has to be an allowance on trying. Sometimes it may be 6 months of effort of tossing it away, but like overall the project's moving forward. But, you know, these kind of small areas that, you know, when it comes to software development for products, is a very different cadence to it.
Yeah, I mean, if you're solving a problem that's already been solved before, these sorts of things typically don't happen. It's really when you're sort of like paving a new path where there are just simply aspects of the project there are no clear answers to. And we had a few of those on this. And those are always very scary. Like, you know, the prospect of working on something for 3 months and then getting to the end of that and being like, oh, well, that was the wrong idea, and having to throw away is like terrifying.
But overall, though, you come out of it with a stronger understanding. Like, there's nothing, it's not a complete loss. And I think that that the kind of the nature of that work, so for example, at ElixirConf, I mentioned how DockYard invests roughly 10% of our revenue in R&D. And I had a bunch of people come up to me and ask me, and then on Twitter afterwards, like, you know, how's that work, blah, blah, blah. And I've told them, I go, look, you have to accept that 100% of that money you're investing in R&D is not going directly towards the production of it. I mean, it is like in a much larger picture, but every single line of code that's being written, you have to accept that there's going to be, for every like 5 steps forward, there's going to be like maybe 2 steps backwards sometimes. And if you're not ready to accept that, if you're not ready to like be able to eat that cost, then you should not be in the, you know, you should not be trying to go about and doing these things. Because it's just, if you're more of like the traditional business sense, like, you know, all the time has to be accounted for and has to be put towards something that is producing potential ROI, it's going to fail. Like the team's going to fall apart. It's going to be frustrating. It's just not going to work. You have to essentially have a lighter touch than that and allow for missteps, for things going in one particular direction. Because as Paul said, this is uncharted territory, so to speak. And sometimes in uncharted territory, you have a good sense on where to go, and then you have to find out that it may be a dead end or a roadblock before, because otherwise, there's chance and risk that's associated with this work sometimes. But overall, the project as a whole continues to move forward at a macro scale. But the micro kind of day-to-day stuff can feel like at times like there's it may not always be moving in the right direction, which is why when we're looking for a product owner for the R&D department, that's been the struggle, is finding someone that understands that particular background. All that to say, I'm going to take this opportunity for anyone that's watching this that maybe has an engineering background, a product owner background that is interested in this type of work, get in touch with us, DockYard.com/careers.
So I'm really curious to check in with Drew and John, because you're getting a glimpse of what it's going to be like 5, 10, 15 years in the future. You're in a room with a bunch of incredibly experienced developers and other. How are you? What is it like is going to be my question. What's it like watching how these people think, seeing the parallels especially, right? Because as much as, yes, they're working on much harder problems, it's a lot of the same type of thinking.
Well, thank you for setting the time frame right there, Brooke. This is John speaking. Yeah, fantastic. 5, 10, 15 years. I feel like like I'm a newbie musician, and I'm surrounded by people that are well rehearsed and that they have had like a 10, 20 years career playing Rachmaninoff. So. But when you boil it down to the essence, if any of my friends who have never written a line of code would see what I do on a normal day on the academy writing things, they would also go like, what's going on? What's all this enum.filter thing mean? It's like, how can you know? So it's good to take that bird's eye view and know that we, as Brian was pointing out, it's just, and Paul, it's just steps in a certain direction. So yeah, once the whole lingo goes away, it's all part of the same process, different stages.
One thing I like to tell like people that are interested in getting into software development or more junior in their career, and they, I first recognized that when I was learning software development, there wasn't as much to learn and absorb as there is today. Like there just is more stuff, and I've had the privilege and benefit of kind of having that iteration on new technologies as they come out. But what I will say is that it will never be as least complex as it is today moving forward. It's only going to become more and more complex. And so, if you want to benefit from that, just do it today and, start doing it, because the longer you wait, the more stuff there's going to be. There's going to be more stuff to learn, more complexity. And so it's only going to be as least complex as it is today. And tomorrow is also going to be the least complex as it will be moving forward and thereafter that. But tomorrow is also going to be more complex than it is today.
So Brian,
I have to sign out actually. Sorry, I'll go ahead. No, question, and then I have to sign out to join another meeting.
Oh, I was just going to say, so Brian, you're saying that better today than tomorrow because it's just going to get worse.
I wouldn't say worse. I'd say that there's just going to be more. And I totally sympathize with the overwhelming aspect of it. But the other kind of like strategy around dealing with the overwhelming nature of technology is go very, very niche. Like find something very, very, very specific and focus on that, and then kind of build off of it. That's why the web is actually, I think, a good kind of entry level career path for engineers, because most everyone's already familiar with the consumer side of the web, and a lot of the development tools being open source is helpful. But also, it will expose you to a wide variety of technologies, but you can also kind of live within one particular niche, right? You, as a front-end JavaScript engineer, you don't need to always understand how the database works. You don't need to understand how to deploy, a server. Those skills are definitely helpful and are going to be necessary as you progress in your career. But as you can start out as a JavaScript engineer and kind of build off of it from there. Same thing with Elixir, but Elixir being a server-side tech, I think carries with it a bit more on top of it. Which is why, Brooklyn and I, when we were discussing the content early on, one of the struggles we had was like, how do we scope this properly? How do do we want to go this deep into databases? Do we want to go this deep into server, setting up your server and all that? And it's always a bit of a tug of war on how much surface area we cover there versus what's going to fit into a 3-month course. And so I think that for anyone that wants to build a career in software, but doesn't want to feel like there's just like way too much out there, there's no shame, there's no problem with starting as small and targeted and as niche as you possibly can and kind of grow it out from there. All right, I got to bounce.
Awesome
Thank you.
advice. Take care, Brian.
Bye.
So Drew, John, you're in a room full of engineers. We've talked about some awesome stuff with Rust. We've talked about general project development. I want to ask, do you have any questions for the group? Things that you've been going through or things that you want to ask this awesome group of, I'm going to say tech heads, because I can't think of any other general
I'm curious, yeah. Well, it's I'm curious to know how does it feel from that other side to see a couple of newbies green behind the ears, just kind of taking their first steps on this. So yeah, that would be one question to ask. Like, what do you think? What do you feel when you see somebody like Drew and me kind of starting in Elixir? That would be one. And the other one is, if you could advise something to yourselves like 5, 10, 20 years ago in our situation, what sort of Gandalf-like advice would you provide for us?
I mean, I love seeing it. I actually have a stepbrother that's kind of in the same state as you guys, just kind of getting his feet dirty and trying to learn how to approach this field, trying to find his first job. And it's exciting because it sort of gives me a renewed perspective on what it means to learn to be an engineer these days. And there's so much you take for granted after a certain point. Information you picked up over the time, you just kind of absorbed, and you don't even think about it anymore, which is good because like that leaves room for you to focus on sort of more complicated things. But on the flip side means that I'm a terrible teacher, right? Like I have no perspective on what I can assume someone knows anymore. So getting to interact with people that are new means that I get to sort of like learn what kind of what the state of the art is, I guess, in learning, and what the problems are, how to be a better teacher, things like that. I guess if I was to give you any advice, it would be really two things. One is more, I guess, soft skillsy, I guess, in the sense that if you, like, burnout is a thing that you won't encounter in your career, guaranteed. It will happen to every single one of you, and you can't avoid it. The key is you need to have a healthy way of dealing with it. That means you have to recognize the signs and just kind of figure out what it's going to take for you to kind of get past it. I basically have a period, at least like once a year, maybe every 2 years, where I really struggle to be motivated to work on anything at all. And that's how I know that I'm kind of in that sort of burnout entry period, right? And I need to deal with that. Usually for me, that means taking a break, getting away, doing something else. I have a couple hobbies that I kind of like dive into when I'm feeling that way. And, that sort of lets me reset my brain and kind of come back to my career, like re-energized, I guess. Early on in my career, like I think it was my second job. Yeah. Kind of first real programming gig. I've been doing programming at a previous job prior to this, but this was like my first, like I got hired because I'm a programmer kind of deal. And it was so boring. I was working on stuff that there was so much bureaucracy. It took forever to get approval to do anything. And it wasn't a lack of interesting stuff to work on. It was just I couldn't actually do any of the work because, I had to get sign off from 15 people, and half of them were going to be like a month before they would say anything. And so I'd just sit around. I had so much free time on my hands. So I spent that time like learning some skills, like trying to flesh out that time, make it useful for myself, which I did. But after a certain point, it got so bad that And I was ignoring the signs in the back of my head that I was really starting to hate my job, right? Like I was lacking motivation. I didn't want to go to work, things like that. And I just ignored it, kind of tamped it down. Well, after about a year of that, I was so burnt out that I decided to like quit programming entirely. I ended up joining the military and, working on F-16s for 6 years. And then when I came back to programming, it was like with a brand new perspective. I got lucky that the first job that I got trying to work in programming again was with a really cool company that was doing R&D around manufacturing, like CNC machining, injection molding kind of stuff. And that really reinvigorated me. I had fun people to work with, people that were really good teachers that sort of sparked an interest in sort of the more, I'll call them esoteric things, but got me interested in things like compilers and so on, to the point where like sort of remapped how I wanted to approach programming from scratch. So it worked out for me, but it could have easily gone the other way and I might have never come back to programming. And it was all because I just ignored what damage was being done to me by ignoring that burnout. So long story short, just would like to say, make sure that you kind of understand those signs. And there's plenty of writing out there that probably does a much better explanation of how to recognize some of that and how to deal with it than I could. But I try and tell everyone about this because it's something that has started to maybe be discussed a little bit more frequently in the community, but is way, way underemphasized. And I think it's sort of something that people don't talk about quite enough. There's a lot of fun and interesting things to do in programming. It's, as Brian said, it's always changing. There's always more complexity coming down the pipe. And that's part of what is great about it, is there's an never-ending source of interesting stuff to learn and to work on. And you got to kind of grab onto that, right? Like for me, that's a major lifeline. I know that I'm never going to get sick of programming because there's always going to be something new to work on. You're not always going to be working on that line of business app that's, doesn't really do anything particularly complex, but, is full of a bunch of legacy code that you have to refactor. Stuff like that is transitory and sort of like necessary at some points. You have to know how to be a good maintenance programmer as well as how to tackle greenfield projects that are complex. So try and like find the thing that you can use as like a lesson or something, a bit of knowledge or wisdom that you think you can extract out of that project and latch onto that as the thing that's kind of your lifeline, for lack of a better term. Beyond that,
mental health,
mental health is incredibly important in every industry. So, but particularly with, I think, a job that sort of lends itself to being sort of more isolated than maybe other careers because you spend a lot of time in front of your computer alone working on code, so there are ways in which that affects us that maybe aren't so obvious. But I think beyond even just the mental health stuff, the other thing I would encourage you is, like Brian was saying, there's always new stuff to work on and a lot of interesting problems out there. Like try and find stuff to challenge yourself with, like push your boundaries a little bit. I think that's part of what keeps things fresh and interesting is if you find something that sort of seems like a problem you'd like to solve or maybe just an itch you'd like to scratch. You want to learn a language or learn how something works, like indulge that instinct and see where it takes you. Maybe where that leads you is starting a business around a product that you came up with from scratch, or maybe it just leads you to an interesting job opportunity because you got really good at, some particular niche and that's sort of like become what you're known for, or maybe you just publish an interesting tool or something that gets you conference speaking opportunities or, an opportunity to write a book or whatever. Like there's all sorts of different ways that, what you spend your time on can pay off in the long run. You don't have to set out to do any particular one of those things, but I think it's always a good idea to kind of just let your desire pull you around a little bit, see where it goes.
Yeah, Paul, I just want to give a huge thank you for bringing up bringing up mental health, that is a huge thing we talk about in the Academy all the time. Like, it's hard going through this type of boot camp. So taking care of your mental health, sleeping enough, going and getting physical, having other hobbies, those things are incredibly important. And exactly what you said, find the next interesting challenge. Web development, as much as right now for John and Drew, it might feel like a 3-month stretch. Web development is a lifelong pursuit. So it is imperative to figure out what you find interesting and to keep chasing that in order to keep yourself engaged, because in the long run, everyone's going to experience dwindling motivation, burnout, just like you said. I know that we're running low on time. We're coming towards the end. So I want to give a huge thank you to everyone for listening, a huge thank you to all of our awesome hosts and guests for joining. Huge thank you to the students. And I think since we've been talking about mental health, I'll just leave everyone who is listening off with the note: take a break. You can take 5 minutes, 15 minutes, or a day or a week. Take some time for yourself, take care of your health, and we will catch you on the next episode.